Okay, good afternoon, everyone. What I'd like to do is just to underscore a few of the points that were made by the panel. And I think one message that came through loud and clear and that I've been getting this morning is that we must look beyond silicon. But the biggest opportunity that we face, the one that we absolutely must not miss, is the silicon opportunity here in the heartland. So I'd like to do that by telling you a story about a native-born Hoosier. His name is Frederick Emmons Terman. He was born in Indiana, moved away to California at a young age. And in 1960, we heard earlier that semiconductors was so 1960. So let's go back to 1960. In 1960, Fred Terman, who was a famous electrical engineer at that point, gave a speech at the National Electronics Conference in Chicago, Illinois. And he made the point that during the last 2 decades, electronics has become one of the most exciting industries there is. So 2 decades before that would have been the 1940s. What was happening in the 1940s? Semiconductor technology was being developed for the war effort, for semiconductor, for radar, for detectors, for radar systems. Some of that work was being done actually at the physics department, just over here across campus. It was a hotbed of semiconductor activity. They were developing the techniques to grow high-quality germanium crystals and learning how to dope those crystals. Bell Labs learned how to do that from the Purdue team, and that was the germanium they used when they demonstrated their first transistor. He went on to say that this new electronics lives close to the frontiers of science, requires a high level of technical competence, grows by the development of new products, and is characterized by the transistor. All right, what was happening in 1960? Well, 2 weeks before he gave his speech, the first silicon integrated circuit was demonstrated at Fairchild Semiconductor in what is now known as Silicon Valley. Fred Terman was a visionary. This is why he's often called the father of Silicon Valley. Now, he saw the future in 1960. This was a niche industry. It was very small. This is a 2-transistor integrated circuit. The largest market for the technology at that point was NASA for onboard electronics in small satellites and spacecraft, onboard computers for the Apollo system. So this was a niche technology at the time. Here in the heartland, we were a major manufacturer of electronic systems, vacuum tube televisions. There was a booming market in the Midwest to manufacture vacuum tube electronics. Well, the point of Terman's talk was about education, about how important it was to this new technology. And he pointed out that for industries like this, education is a raw material. It's more important to be located near an educational institution than near the markets, raw materials, suppliers, transportation, or factory labor. That's even more so now, and I think you heard in the discussion from MediaTek and SK Hynix how important it was when they were selecting a site to be located near a major research university. It's even more important today than it was in 1960. He also went on to say that graduate education is important. And Patrick Wilson of MediaTek mentioned this earlier, that a minimum of 1 year of graduate school is important for the kinds of industries like this that are working at the cutting edges of science and technology. And he said a PhD is even desirable. Now, he went on to point out that in the Midwest, there hasn't been a lot of emphasis in that time period on graduate education. He pointed out that California produced more PhDs than Illinois, Wisconsin, Indiana, Michigan, Minnesota, Missouri, and Iowa all put together. Okay. So he really made a strong point about how critical education is to technologies like this. It's even more so today. Now, this was actually a very blunt speech. He was a native-born Midwesterner. He was urging his colleagues, don't be left behind. This is where all of the action is. He pointed out that electronics in the Midwest lacked the explosive character of this new electronics. All of the brightest young people wanted to be in California or in New England and work on this exciting new technology, even though it was just a small niche. So he pointed out that the Midwest has an opportunity. We can be part of the excitement. Well, I guess we all know what happened. We missed the boat in 1960, right? The semiconductor industry didn't come here. Silicon Valley became Silicon Valley, and other places benefited in this. Okay, but what about now? What's the situation now? Well, we have a CHIPS Act, and we heard about the CHIPS Act earlier from Dr. LoCascio. A part of the CHIPS Act, $39 billion, is incentives for companies to build factories. Most of those dollars have been committed now. That $39 billion of federal investments has stimulated over $300 billion of private investments, we've heard. So that is leading to perhaps a tripling of the semiconductor factories by 2032. The other part of the CHIPS Act is for research and innovation, and that began with the Department of Defense Microelectronics Commons program. Illinois and Indiana are partners in the Silicon Crossroads Microelectronics Commons Hub. And the $11 billion that Dr. LoCascio pointed out in R&D and innovation is just beginning to roll out now. And many people think that that is the most important part of the CHIPS Act. And our colleagues in Illinois and our colleagues here are working very hard to be part of that innovation ecosystem. Now, what else is happening here? If you look at the history of this technology, so we began in about 1960 with the first integrated circuit chip. That was the first wave. We put more and more transistors on a chip. Electronics got more and more powerful. And then things began to slow down because the wires to connect all of those transistors started to slow down the operation of the computers. So around 1990, we switched to more conductive wires, copper metallization. It doesn't sound like a big switch, changed from aluminum to copper, but it was really a very significant technological challenge. That powered the second wave of microelectronics performance, and performance began to increase. Now, about the year 2000, many people thought we had reached the end of silicon technology. And we had to look beyond because we had reached the limits of microelectronics. I wrote a perspective in Science magazine in 2022, and it was titled tongue-in-cheek, Moore's Law Forever. And it was basically to point out this technology has a long ways to go. And I think Patrick quoted some numbers earlier. It was a $50 billion industry in 2000. It's now a $500 billion industry. So we didn't see the end in 2000. We started the third wave. We made transistors so small that we had to change their architecture and make them three-dimensional and go to technologies driven by FinFETs. And now we have almost reached the limits of that technology. And we're beginning the fourth wave. The fourth wave that will drive the performance in the future, that will satisfy this insatiable demand that AI has for computing and memory, is heterogeneous integration and advanced packaging, putting different chips, multiple technologies inside the same package in such intimate contact that they function almost as one large chip. So the fourth wave is just beginning. Now, Terman also talked about how important education was, and that in the Midwest we weren't paying enough attention to graduate education. If you look at Indiana and Illinois and the states around us, today we have 26 universities with engineering programs. We have 20 R1 universities in this region. We have 3 of the nation's top 10 graduate engineering programs. We have 4 of the nation's top 10 producers of BS engineers. We have 3 of the nation's top 10 producers of PhDs in engineering and computer science. And it's not only workforce and talent, but it's research as well. We conduct more than $1 billion worth of research. We have 2 national labs, major electronics centers, and Air Force Research Lab, Crane Naval Surface Warfare Center. So it's a much different environment than it was in 1960. And semiconductor companies are seeing this. We're talent rich, we're leaders in research. So you're beginning to see the ecosystem emerge. Intel opening its plant east of us in Ohio. Things are happening here we've been hearing about all morning here in Indiana with SK Hynix, MediaTek. IMAC, the world's largest independent R&D organization, is establishing a presence here on campus, and they're with us here this morning as well. In Michigan, KLA Tencor is growing to support the semiconductor industry, and IMAC is developing a partnership there as well. And in Illinois, IMAC is developing a partnership with our colleagues in Illinois as well. Entegris, which is a major supplier of materials and chemicals to the semiconductor industry, will see a growing business as this ecosystem emerges here. And I believe Entegris is with us this morning as well. So things are beginning to happen, and we have a tremendous opportunity. We can become a major center of semiconductor manufacturing in the US. We can also become a major center of chip design, beginning with companies like MediaTek. And research and innovation, we can be part of that innovation that will drive the industry ahead for the future. And we're also a source of excellence at scale. We can be a major source and a supplier of talent, not only to the industry around the nation, which we have been for years, but we can reverse our brain drain problem into a brain gain opportunity by creating more jobs for engineers and other STEM majors in the semiconductor industry as it grows in the Midwest. So I'll end with these thoughts. Semiconductor technology is absolutely foundational because everything else depends on it. We live in a digital world. No other technology will be as transformational as semiconductor technology in the next 20 years. I'm confident of that, and probably for much longer. We'll need technologies beyond semiconductor technologies. Quantum will play a role in the information processing ecosystem, but it's going to be a semiconductor ecosystem as far as we can see. And from a scientific and technological and engineering perspective, we're just beginning the fourth wave of semiconductor technologies. This is an exciting time to enter the field. I had a visit last week from a major semiconductor company, a gentleman of just a couple years younger than me, who said, "Mark, I'm so jealous of the young people today. They're entering the field at this exciting time. They're going to have decades of fun developing this technology ahead." So I guess it's actually 64 years. If you had asked me 4 years ago, what are the chances that we could create a thriving, vibrant, growing semiconductor ecosystem in the Midwest, I would have said 1,000,000 to 1. It'll never happen. Then we had COVID. Then we had a CHIPS Act. We are in a much different situation now. This is our opportunity. We shouldn't kid ourselves. It's going to be challenging. It's going to take a lot of hard work. We're going to need to stay the course. But we can create a thriving, vibrant semiconductor ecosystem that grows here, creates more and more jobs for our citizens, creates opportunities for our students. This is our opportunity, and we should keep our focus on it. Thank you.